Good evening, everyone. So let's start today's class. Okay, fine. So, good evening once again. We can hold the class or see. We can get can okay. So, Queen Rank Iogre, do Marie Yang Sika. Or see the seeking of those other minimize to the other. Okay, you know, minimize to the oven trainer. Yeah, the share screen door. All right, so see there now. When a Kyogre have and see. And what else? What else? Okay, fine, ma'am. Can to is Sanangang is Tabra? Venamak?
Dai, sir.
Hi, sir.
Okay, fine. So, Queen around can only Bernoulli's principle. So, sir, Bernoulli's principle, sir, and direct to is the Ganta the Bogami Yaura. Hainero, Ta, Venamak Tabra, Tadami Yaura. Tarsu Tai Hero, Tadasu Tadahero. Tai Evaka. Okay. All right. Is it still available? Yes. And one more thing. Oh, so my number with the idea. Okay, talk to strange. 1 second. She's talking to again. Talk to again. Nangi no tigam sin na ipot si tolok to si kay gino have a took it strange way. Then files the channel. Kay talk to no in. Oh, she there. Alright. So, Queen Kyogre have the mechanical properties of fluids. Now, fluids ki matang turning streamline flow, now Bernoulli's principle, and then viscosity and blah blah sigma curl. Now, sir, na Bernoulli's principle they explain toning curl ka. Do su toge. So let's continue ka. Now, sige sida no na sir nangarang sumay di kitang tunay ta isa ju pro wa bagi ka. Fazana noida any explanation loina kitang pain the high or whatever. Happy chalkum han guess you did no kanga manika. Edi do we have the sigi quina x taina y for the labor fluid c x taina x the lemba sigi fluid kis just suppose let's consider the fluid which is which lies between x and y then x in x dash the y and y dash go do never fluid is my check do never go chatpa matam jida we have the sidalaiva som the labor fluid ki particles in pressure pressure some side pressure now CC have the CG pressure CG fluid CG left the fluid in the right the flow of my force C from left to right and then CG sidana particles in the right the fluids in the left the right the flow the force have the force in left to but magi fluid ki displacement or velocity the positive have the left to right the ani negative for have the v2 delta t jina v2 delta t direction jina som the way neighbor so c to v1 delta t direction som the neighbor but f2 the opposite way because c is f1 positive way but c is the same direction way in positive way c opposite direction way in negative way because c minus like maram do adu do you want give c area into distance, velocity into time, the distance, so area into distance, the volume, so volume to the mass by density, never. Density to mass by volume, so adu na chingba, ma'am, haitare ka, aram kitang two na tormanina, density, have a see, is has a oil in a reckoning, density has it can have the mass by volume, never. This is volume, not some नत्रगा इसुमा हाइसा mass by volume ji kai hai sike dum volume ha ge ko kai no di velocity ju yaw bani na ngaw gudra khali bai na ko anyway so adumai le ko sidai sida dai di mathang da si pa le ko duga sumai to derive to tare now sida le isi kan the pressure plus rho gh plus half rho v square ko si sina ke da inertial pressure static pressure kinetic friction kinetic pressure na hai ko so si kedawa Bernoulli's principle aduki matik phajai ko magi kanaba myamam lei aeroplane naga pai bisi kamaina pai no sir harake ko muneu aeroplane gi noina nei keno to flight tong mi adum yauna ramani ko so sir gi haziki sir hazik taiba class se recorded session yengba anyone any person whether NEET ki aspirant ho gira JEE ki aspirant ho gira 11 12 ka ba student ho gira angang mocha ho gira ahan ho gira layman ho gira anyone hai tare si recorded session tari bise ko noina flight tong matam da wings to yeng over ko aeroplane gi wings se ke do nia matam da mazi sumaina to ga ke do ba sumaina kitang ko sign to kra sumai si gi shape si da mana lift generate to matam si streamline shape ko we ko anu somna kra thani somna kra thani ode si na kra pa ga ni ko and then distance wind ji sumaina flow to ko matam da ko wind ji sumaina flow to ko matam da si na ka haidi distance ka nak ka ne ba mathaki sina ke dawni ha sumaina kola ga lakani ba ko auna di ke dawni ha matam da sida di haidi sigi objects aeroplane or whatever si the same speed junction ga doine ba now sigi position ji da leramba wind particles sing do mathak tai chatpaduga makha de chatpaduga makha de jin shorter distance ne ba si yobu da mathak tai jin longer distance ne ba adu di mathak tan speed chi yang oidra yang ga ni ko kai it has to cover longer distance hai tar sir na hining is gyan tabra ta dabra myam
Tai sir.
Tai ko aduna di kai do we have matam da 1 second si se ina kena to ning bai tar ko 1 second ai si da kitang kena ma sem do ke to si subsan ba ju ya de ba to se ko oh ya bra ya adu si kitang ka na subsan lo u da bin to se okay 1 second anyway yare ko so sir na hining is kain habda si plane gi wings to ne ba ko aeroplane gi wing gi shape to sumain to raga lei gi to ne ba ko wing gi shape to si cross section ne ba aeroplane gi wing amagi cross section ne ba si se gyan dai ko hai je aeroplane ji sumaina chaung lei to ne ba gyan dai ko si da thongnau me pa la ni or whatever hai ta ko sumain to chaung lei de ne so this is a cross section of a wing hai ta ko magi auna kaidoni ha matam da mazi sigi shape si da laini aduna kaidoni have the mathakta chaliba nungshit sigi velocity ga makha da chaliba wind gi velocity ga mathakta ne yang ne ba so according to Bernoulli's kedoba principle if sigi terms ino chokolak pa tar ga di ko si mang di se kai gino si dum yo le se kai gino I don't know it's wrong yare ko so kedoba sigi terms ina sigi velocity gi terms adi velocity yang kala gadi kedora kan have the same height ne ba kashu height difference kashu am leiba na te ba ko sigi ani ja up ka down ga si kashu height difference leiba na te ba abdi height number more ga pressure difference to leiga da kashu leite ba abdi kai na matam da pressure difference ka ji kai na the height yam tin kenar kan da kedoba again density du ne am kan wang kan da yam na queen significant or kwane ba air gi density ji we have the troposphere or troposphere stratosphere from or any air density kasham kana vary to debo kena boy debo ko aduna rosy hc we have matam da significant oi debo sigi matang ji da ko insignificant never rosy hc aduna di kaina the pressure ga sigi ana velocity di yankala ga di sigi tam de chokuleba si tam de chokula di ke si tam de picture da ya debo kaino di hom sigi sam je constant oi de ya debo according to Bernoulli's principle ko aduna we pressure lower kaneba aduni pressure ji lower ko tardi mathaktana kedawi mathaktana magi velocity se increase to weba makhad adi increase to we have udi ya hoi makhad increase mathakta increase to makhad na increase to we hagra decrease to we hagra makhad ka tap kaneba gyan dai ta de tai ko so let's say this is v up and let's say this is v down auna aduna kaidongni have the velocity up is much greater than velocity down haitare. Aduna di kaidongni have the pressure up will be much less than pressure down. Auna always force habisi high pressure de low pressure de chatkani bako. Auna makhagi wind di high pressure the leni mathaki wind in low pressure leni auna high pressure de low pressure da net force net upward force ama lakani ba ado indo lift generator kadini ba. So ma'am kano to easy sir na hajikta explain to easy gyan tabang ambra. No response. Taiko. So tadragadi tadidum have ko. Adagi noida kano maga yengan ge ko. 1 second. Let's open YouTube. Oh, sorry, sir. Let's say kidova Magnus effect has a Magnus effect ka kidova Magnus effect the board of matada by to the your frames ka. See Magnus effect CC kitang tien bra. Okay, fine. So let's see this video ka. See video see yeng see kamay yeng sige have the aizu earpiece to kano hapsra. Okay, hapuragi ka. Yeng ko sige. See yeng siko ma'am. Add some tolerances. Okay, fine. Ko. So let's start. Ko. Ma'am, video si tabra hero sounds.
Tai, sir.
Tai ko. Okay, fine. Yeah, tao ko.
Some friends of mine went to the Gordon Dam in Tasmania, which is 126.5 meters or 415 feet high. Then they dropped a basketball over the edge. You can see that the basketball gets pushed around a bit by the breeze, but it lands basically right below where it was dropped. Now watch what happens when they drop another basketball, this time with a bit of backspin. Whoa, look at that go! One day to get back in the water, dude. This is great when you throw it. I literally just dropped it with a bit of spin, like I didn't even throw it, and it just took off. I had no idea that I was going to do that. And this is where I come in. The basketball was subject to the Magnus effect, which affects all rotating balls or cylinders as they fly through the air. It works like this. As the basketball picks up speed, air on the front side of the ball is going in the same direction as its spin, and therefore it gets dragged along with the ball and deflected back. Air on the other side is moving opposite to the ball spin, so the flow separates from the ball instead of getting deflected. The net result is the ball pushes air one way, so the air applies an equal force on the ball the other way. And this is known as the Magnus effect, named after Heinrich Gustav Magnus, who described it in 1852. Of course, Isaac Newton beat him to it by nearly 200 years, describing the flight of tennis balls at Cambridge College. But, you know, he's got enough stuff named after him. This effect is very important in sports like tennis, soccer, and golf. But could it have non-sport applications? Perhaps. This is a sailboat. I know it doesn't look like a sailboat, but those aren't chimneys. They are spinning cylinders called Flettner rotors, and they take the place of the sails. They deflect crosswinds using the Magnus effect to propel the ship forwards. And this is a plane with spinning cylinders instead of wings. Using the Magnus effect, the cylinders actually generate more lift than traditional wings. However, they also generate way more drag, making them impractical. This plane only flew once, and then it crashed. But the Magnus effect is making a comeback. Here is an experimental rotor wing aircraft, which generates all its lift from spinning cylinders. And this is the E-Ship 1, which uses 4 spinning cylinders, that's 4 Flettner rotors, to increase its efficiency and reduce the amount of diesel it burns. So in the future, the Magnus effect may help more than just basketballs.
Okay, fine. So, now let's come to the Western. Let me explain all that. So, we have the ko aziki koina ball ji makhada thadaba matamda chumna thadaba taragadi ball ji straight ta taiba ko ball ji kedo aina chumna thadaba taragadi ball ji straight ta swain tarakani ball ji ko but ball ji ne kitang back spin swain back spin tawraga thadaragadi kedo ball ji straight ta tabra ta de ko ball ji sumain tawraga sakibra habidi aina som side te ball ji kedo ba sumain tawraga chumna thadaba di straight ta tarakani ba but kitang back spin tawraga di ball ji sumain tawraga sakidana ko sumain tawraga yam sangna sakibane ba yai ko yabra da bro
Yai sir.
yai ko so adugi potu kai have never balls it had a matam sumain set creed have the sumain torga sign to some the light kai have balls had the chumna tadargana sumain taba but kitang back spin the have the back spin asom side to go back spin the sumain tor balls it had a targadi sumain tor chakhi ko sumain to chakhi now cc kai have the Magnus effect, Magnus effect is an application of Bernoulli's principle. So Bernoulli's principle ki matungina kaya we have the ina hazik can we talk about diagram ye gata ke let's say kaya we have the ball Z let's say this is the ball and ball Z minus spin to Z kya ball Z let's say man back spin to so minus spin to reba ball Z ka adu ragadi ball Z na makhada sum tarak matamda kaidorakani ha matamda ko wind je nungsit je sida laani ko sida sulakani nungsit mayam ama ko sida sulakani somda sulakani aduda kaido we have the balls ni makhada taraini ko spin to taraini ba kaini silok to kusa hati je gaina strong okay fine so kaido we have the balls so minus sum makhada tarani tarakpu matam sida na sigi wind gi velocity je somga asomga ji kar mana yang ne have the somgi velocity is in a somgi velocity is in let's say if this is v2 and let's say this is v1 v1 will be much smaller than v2 v2 is the yang ne ba kai you know the ball na spin to ningi ba direction ji som da ne ba ball na spin to ningi direction ji ko adu wind na chaningi direction som da ne ba and wind is smile la the ball in a drag to raga ball is spin to rimina some see the vacuum decrease to ya damnina see they even to see of the neighbor see they even to see of the neighbor but see the even to say see the even to see of the Changamatam Duga see the even to see of the Changamatam Duga some is in Amtina Hani some is Tapkaniba Kaino Saharakeba Kaino Hamatamda some is the balls in Masam spin domina bolgi surface to not drag to Ganibanum Chiche the two university some is the kind of way balls in a minus spin to nungsit som the chain na bonare adudi kay dorakane habdi amana amaji opposed to kani nungsit to freely chain be aro ball na chingthara ne ba nungsit to auna net velocity of the wind si som side te tappe ba som side te na yang ba adudi kay dorakane have the obviously v2 na yang oidra v1 dagi yan daita de
Dai sir.
dai ko adudi kay do we have the velocity yang na di pressure si kay do we pressure si aduna P2 will be much less than P1. Adudi we have the P1 to P2. Habedi pressure high pressure the low pressure the force net force always high pressure to low pressure ne belai duse. Auna we have the balls that tarakpa matamda magi trajectory si ko sigi ball si sidagi tarai ne ko si arrow si budi yaw ngamdre. But 1 second. Let's say Beranji erosi kamaina kida way out now. See bolzika tarak pamatamda sumaino in tarane then sumaino in tarane pair sakrane then sumain toroga in a sigi pachido in tagrane straight the tar gyan daita de taiko I straight the tauya the bimarum do straight the ta the bimarum do kangaba kangego Sidagi sum bolse tare, sidai tare sum tare, but sumaina paira sakini bako. Paira sapai maram du kai I am matamda always have the some side na velocity yang duinina. Kai doni have the velocity yang di according to Bernoulli's principle, velocity yang di pressure si low irani bako. Aduna kai doni have the pressure low iragadi high pressure to low pressure da force net force am to bol sumai to pai gini. Pai ne sakani ba. Adumaina tawdana sarna plane paibagi matang dasu high grade plane ji kedobagi keno to ina mathaktana wind gi speed se yang eba makhaga yeng narubda auna mathaktana wind gi speed se yang amnina pressure low oirani ba auna makhada di mathaka yeng nordi makhana di khara tappe ba auna pressure ji high oirani ba auna high pressure to low pressure lift generator aeroplane ji paini aduna ne ba khoina aeroplane tongaga thada chatpa yagada yaroi ba aeroplane ji stratosphere gi lower stratosphere de hena pakatpa yade ba kaino ni nusit leitradi aeroplane pai ngam de ba gyan da rise Bernoulli's principle na work to is the fluids taneva it could be liquid it could be air it could be gas but without any kedoba air hai atmosphere leitragadi Bernoulli's principle is not applicable mayam gyan tabra tai ko
Tai.
adugini aduna ne koina special rockets in the Newton third law haidi mass habdi kedoba ngasai gi Newton ni third law sizinaraga koina thada chatke harga de satellite launch to widi plane na ya deba ko aeroplane so again atopa ke example pvi hamatam da noina haziki keno sigi ko aeroplane pai beta the bird ki wings kaise bird ki wings kai no idum yeng uchek sing na pai matam uchek sing na pai ju kai do ni ha matam da again before bird wings ke do ba helicopter ki wings ya flat oi da bane ba helicopter wings ji sumaina ju kitang cheptha ni ba ko ai di mai thrust generator one adu khatang nat bi ma gi je mai thar ga pathar pane ba si gi shape ta to bane ai di si ji gi shape ta lai ni ba helicopter gi wings to ma gi sorry helicopter gi di wings haina bra wings adu mai na male ko ma gi fan hai ga mai pankha do ko magi masa sing do helicopter gi adu du ke do we have da magic cross section ka that pa matam da ne si gi shape da lem ne adu from the forward direction the move option do ne ko back hal laga di helicopter pai khat pa sunga roi ko helicopter si direction am da khatang rotate to ni ko ai ni magi ji gi wing gi shape tu matung ina maning hal la sumai pai khaloi ba lift generator roi ba adu gi ne yare ko adu da gi di atopa kai sometimes noi kaino theng na bra labuk ta ga chatpada lamhang da ga chatpa matam da bird sing hai tare ko kai ni uchek khar chawba langjao egera any uchek sum mathak ta sum tar lai ba theng na ba bird sa adum tar lai ba sung theng na ji ba
theng na sir
chip mathak tai di ning da ba sung ning da ba tar lai ba aduna di ai sometimes ngak pane ko angang uri ni na eba uchek si mathak ta tar lai ba tare kem la di lieng da bi telanga pai bai ta adum tar lai ba so adu kai yin ha nungsit yam kan si lam ni ba mathak ta yan dai ko nungsit sit panina kai dong ni ha ba da mana mai wing gi shape to sumaina hajiki kai do ba aeroplane gi wings na sumai thek ta ba do adu type ta mana wing gi shape se sumain to raga haidi sumaina kai hani sumain to lai du ne ba aduna wing ji na haidi nungsit yam kan ko flow to raga sumaina chatlani makha daina si bak long chat krani ko mathak ta ni sang na chatlani adu ke do ne mathak ta di velocity jam yang ne ba makha da velocity khara tapani ba ko adu di ke do high velocity di low pressure the comparatively lower velocity in high pressure to low pressure ke do lift generator ne ba adu gi lift generator du na ne ma do makha tarakti da tar lai gyan tai ta de tai ko tabra tai so adumaina tawdana akoina ke do we have matam da no gi ngai kai gumba football gumba heng bor gadi football gi da FIFA or whatever ko haidi corner kick ka hena bu ko adu gi du da akoina corner kick tai corner da gi goal post ta kaursala ga akoina ke do we suppose let's say this is the goal post ko and let's say this is the field kitang budi keno oitre ko sana bu wale but adum khallo sana re na ko now sidagi ball je kar ka du ne ba now aina mathak ta yeng tha matam da ball ji clockwise to spin to hundura natra na counter clockwise to spin to hundura hairo anti clockwise or clockwise ball ja si car ga si da chanan ge ga khoi ra ga chanan du ni ko ball ja karam direction da chanan ni mathak ta yeng tha ba da clockwise or anti clockwise saja ina ro
Anti clockwise.
sengabo anti clockwise na ne clockwise oi draw habidi winzi kamaina flow to rokania ball ji na sumaina passion ma matam da ball ji si yorani ko ball sing ha le ga adudi ke do ba nungsit si sumaina ne ba la ka du si gi direction si da mana clockwise se sasal ga di si velocity yang oi velocity yang di pressure low oi ram ni na asomna move torok to inatro ana clockwise direction da chalo drop ball se mathate yeng ta bata gyan tai ta de
Sir, sida sana to is clockwise lo. Si anti na to bro.
oh si anti clockwise la okay chume you're right Anjalika my bad I'm sorry my apologies this is anti clockwise ka I know okay clockwise ti som do igadam ne na cha chume ai nga tang bab se ne anti clockwise ti som igadani clockwise idini ma'am gyan ta bra kanam kumak tre to is gyan buta bro sigi se haidi clockwise ta chatka duine ja
Anti clockwise na to bro.
anti clockwise ta satwini is gyan ta bra ba Christina Lakshmi Sahila Saitabo Sintoi Sunanda Anjali budi haji high grade taiko ma'am so this is anti-clockwise not clockwise ko aina clockwise and sum high le to is anti-clockwise direction da ni ko anti-clockwise direction da kawgadam ne ba balls je adu da kai do ba si goal ji da phaire satkini ba ana ai straight to go straight to pai ga ni ba adu aina clockwise to car na phaidu sakra ni ba som da anti-clockwise to car on som da in phaijan gra ni ba ko so see kai no this is an application of Bernoulli's principle yare ko adu ain to no koina tennis se lawn tennis hoigera table tennis hoigera tennis sana matam dasu and even akoina cricket ki ball lang matam dasu spin ga haido spin jil lang ga ball je masa matam da high pressure to low pressure ball ji mai chapam thoko patu chatte ba phaira chatle ball je gyan dai ka adu gi ne koina spin je dukimatik maru wer ji da ka lei je ka adu main lei so all these are applications of Bernoulli's principle adu sir nang noi the high grade kaidoba koi stroke to hai ju kai no the application of Bernoulli's principle hai stroke to was Bernoulli's principle sijinar ga explain to go ne ba stroke si kamain to we know na ko aduna id it's a very simple kaidoba application hai gadra or case of Bernoulli's principle myam loni mag yari ko gyan tabra ta dabra
Tayo sir.
Ai ko okay fine that's great now let's move on to the next topic C kaino habda kaino tawgrena ko khoi efflux tawgrena speed of efflux tawgre ka mathangda Torricelli's law in torsira ka Torricelli's law torsika speed of efflux or Torricelli's law I think that's same ka now Venturi meter is speed putokwene but again I don't think it's no in exam gi relevant oi bakra what le so nasai si YouTube kidoni so kedoba dule ka now streamline flow layer the speed of ejection of the liquid through the holes again it's very simple now Bernoulli's principle the base of a question kira hole ani ka okay so let's solve some questions and then we'll discuss viscosity ka now see questions discuss so adu noida 2015 gi matung da hangiba question le ga sir da thajalo sir dum solve toge ka yam layer ga budi characters wi are noina luni na khala ga sir da thajalo ka okay fine so the cylindrical tube of a spray pump has radius capital R and one n of which has n fine holes each of radius r. If the speed of the liquid in the tube is v, the speed of ejection of the liquid through the holes is an k. So it's a very simple example. This is the equation of continuity. Cylindrical tube of a spray pump has radius r. So sumain to spray pump whatever. Let's say sumaina ma lain colors spray pump has radius r magi kitoba let's say see the piston num layer sign to piston num layer ka so this is area of cross section A so see the hole z macha ma'am layer heta ka hole macha ma'am layer now hole macha ma'am z magi kitoba hazik kedo we have the quina we know A1 V1 is equal to arga let's say n times of kedoba A2 or let's say small a A1 V1 capital one is in again this is not volume nico A1 V1 is equal to n times of a1 v1. So my haja is radius r, 1n of which has n fine holes, each of radius r. If the speed of the liquid in the tube is v, the speed of the ejection of the liquid through the holes is n. So it's a very simple question. The v1 machajidi kaitane have the a1 v achova v achova 1 v1 divided by kino n times of a1 tare ka. So which is equal to cd pi harga r square, so n times of our a1 di kino pi r square macha ka. And then velocity v1 zibudi dum v irage lower do the pi ka kre ka. So v r square by r square tare. So kai tare cd v r square by n r square. So option number D tare ka. Yung meron ta sige sige. Option number kai tayo. Yung abo. No response. Kanang respond to sige kay gina. Ta bro ma'am.
Sir, D tayo.
D tayo ka. Okay, so sir na solve to isi gyan buta bro. Equation of continuity ne palize.
Tayo, sir.
Okay, Anjali matang kumeji kay gina. Atay di gyan tahu bro ba? Christina, Lakshmi, Saila, Saitabos, Sintoy, Sunanda. Gyan tahu bro? Tahu da bro?
Tayo, sir.
Tayo, sir.
Tayo ka. Saitabos ta bro?
Sir, nakatang chappudu. Amtang hayu.
Sisi the policy equation of continuity ne ba? Okay, Sintoy ju chet kume ka tayo sir na ka. Equation of continuity ne ba sisi? Equation of continuity hai kay na habda. Sir na ngang taki bido. Area, the product of area and velocity, the area of cross section and velocity is a constant ne ba. Aw na ako'y na ngang tawag bido kay na habda. A1 V1 is equal to A2 V2 ang tawag bido. Now, sige sida di kay na habda. A small a1 and small v1 or whatever, small a small b zim am yame buka aduna sis any 1 1 tapi si kay gina si 1 1 ga tap to yare ka kay no di si pajaro 1 tap di ka b achobani no 1 gam to tap no please yeah so yeah ma'am sige ja Sisi the pali say equation of continuity ne ba ko have the area into velocity say kedo we have the it is the sigi mana kedo mana push to riba delta m do mass to or volume do adu the sidagi thoki du ko chap mana do ina traba au the sigi thoki sidagi aina kedo we have the ngasai aina nga equation of kedo ba continuity derived to give do have the my volume the kind of pressure into kedo ba area have the ngarang kuina kena to budo ko derive to budo magi volume di kaina have the sorry pressure has density have ko the density is equal to mass by volume ni dana ko aduna akoina kedo we have the ngarang do explain to withdraw to is ba mass kaino have the density into volume tare and then density constant ni ka crab volume di kaino area into velocity ni auna sigi sum total do adu ma'am do mana ni na haibane ba ko this is an application of equation of continuity hai tare sisi gyan buta gadro ma'am gyan tabro ma'am loina ma tabro ta dabro
Tayo, sir.
tai ko
Tayo, sir.
area
Tayo, sir.
okay then velocity v sida su tolai je v sida su tolai je v ka aduga sigi velocity in b achoba yale ka now let's move on to the next question question number okay Bernoulli's principle ka a small hole of an area of cross section 2 mm square is present near the bottom of a fully filled open tank of height 2 meter. So rate of flow of water through the open hole would be harga. It's very simple, but we have the rate of flow say volume by time the pyramid ko aduna sisima section gadam ni ko id akoina we have matam the velocity na higher gasu rate of flow higher gasu akoina pango to hochan bado di magi answer do option the lay dimension do sometimes yeng the ya de ko aduna adu do section gadam ni ka cross section ai kitang chap kitang kena to bre anyway adum ya ni da ka kakre da ma chira. All right, fine. So similarly and lower. Yeah, Reka. Now, a small hole of area of cross section 2 mm square is present near the bottom of a fully filled open tank of height 2 meter. Taking z, the rate of flow of water through the open hole is an haiba. Sisi noi haigadra? Haini heroi. Now, kuina kai kangi velocity is equal to ngarang kai tagi 2z h tagi. Now, c velocity is the meter per second the lay gadam ni moi gidi kai the lay. Moi gidi kai the lay. Moi gidi meter cube per second the lay or the volume. Adu di kai don't have the c area amni into tare ka. Have the a into v tarne answer. Gyan dai da de. Tai ko cc sir nang derive to gravity ka. So area di kai tani have the 2 mm square ne on pi into mm ze. The 2 the mm di kitang ni nungai ko 2 by 2 mm ko the 2 by 1000 ta ni amuka zoom ka kai do 2 by 1000 ta ni pi r square le ka area into root over 2zh. So root over hai 2 into z je kai lo hai moina z je 10 lo hai h je kai lo hai height je kya na at a height of 2 meter 2 lo ro ka. So it's a very simple question then. Adu ergadi hazik kai tarni hai matamda. So this is equal to 3.14 into C2 square 4 ni na hazik dora kani have that 2 into 2 4 into 2 the 8 la ni ko 8 into root 10 mathakta ka adu di my z 10 ko root 10 di fractaroidra ta ni ko root 10 je hot ka ta ja the rate of flow water through the open hole would be again yam nungaitaba number ni ko anyway root 10 c ina root 2 into root 5 have you kana de so root 10 ang putok tare pa lete. So this is root 10 into 10 to the power kaino 1 2 3 4 5 6 10 to the power minus 6 there. So cc ni ko lo aduga answer ji tarani ko. This has to be root 10. Now let's do it. Of the 8 4 again, let's do it here. 3.14 into 8 so 8 4 32 8 1 8 9 10 11 8 3 24 25 so one second all right so one second kidoba zikida 8 3 24 20 8 1 8 9 10 11 yeah so mine 25.12 lay ka see the root 10 into total never so root 10 di kai ta ne have the some might 3 point something ta ne do 3 point something do
3.16
yes adune 3.1 3 log so lage 326 313 point number aduga 53 15 326 7 so somewhere around the kidoba 3.14 into 8 75.36 taba ka aduna moi si taram do male 10 si power zi kaino ma soina weta to zi kai no 10 zi power ma 3.14 cernitizina 7 moi si 8.9 zi taram do male ba 8.9 naktra 7.5 or gadi uneasy marak si the lay ka do ni ba ka ai ko kai de soya ixe see velocity ka into area of cross section money area of cross section so pi into r square 2 square root 4 Okay. 4 into 2d 8. 8 into 3.14d. 8 4 32 3 24 25. So 3 no toro 3 to 6 3 1 3 5 3 15 3 to 6 7 75.36 tare. 3.1 where maybe 75 take it and helakadene, but it's nowhere near this. Kai is where is an this.
Sir,
Mm.
asi 2 by 1000 ja. Ito amatang udong na tro.
Kai yamatang with the oh
Madi cross
area of cross
area
section. Damn it. I thought it's radius. I do in a pi square low is it? Pi to lower it on the pi is your record. I know questions the IDC say 2 mm square 2 millimeter radius in color record. It's area of cross section. I do get the answer is the lower. Thank you for pointing out. Answer is the lower. I do not sure is. Adu over targadi kai tarni have the 2 into 2 the 4 ka 4 into 3 12. How the 12.6 taramani answer? Taramani? Tarba. Yung tare ka. See sumo what does you have a question here? In radius ki wakan the color 12.6 tar answer into 10 to the power minus 6. Sardi ka mind kang iba na haragadi. She said 2 by 1000 and a aduga. Is it? Yes. 2 by 1000 at 2 by kadoba. Area ni na ka. Area C 2 mm ni na ka. 2 mm C ay na kaino do onthokpa matamda meter square do onthokpa matamda 2 into 10 to the power kadoba 2 into 10 to the power minus 6 la kaniba ka. Kaino square ni na ita. Have the 2 millimeters onthokpa matamda 2 by 1000 meter neba ka. Now 2 millimeter square on to the 2 by 1000 into 1000 meter square la kaneva. Gan tai ko isa on 2 into 10 to the power minus 6 la kaneva sis. Lay ka aduga CGD sidum lay jare aduna 2 ni into root 10 lay ni ka. Now root 10 to the na 2 adu this kai lay have the 4 by 4 into 10 to the power minus 6 ko higher this is equal to 4 into 10 to the power minus 6 into 3.1. So look, okay, the root 10 is 3.1 mukta iba again. Yadra me amlo muksi se. Kyan tangamra?
Yani sir.
Yan.
Yani ka. Okay, fine, great. So now let's move on to the next question. Question number 5. A wind with speed this much blows parallel to the roof of a house. The area of the roof is this. Assuming that the pressure inside the house is atmospheric pressure, the force exerted by the wind on the roof and the direction of the force will be. The action of the force will be upwards, and the force ki magnitude it's so simple ka. No ECC, ngamgadra ngamudra. Sir, nadum solve to sira. Sajay na ro. Solve to sira.
sir.
Okay, fine. Now, do we have the, let's say this is the roof. Ka. Sida ba? Nungsit sida chatle but makada di nungsit amda chatte ba. Aduna sida di kay no pressure si atmospheric pressure PA ba. And sida lay ba pressure do di kay no. Sida lay pressure do di ha matam da nasagi kay ba queen according to Bernoulli's theorem ka. Kay we have the matak ka makaga zi equation si ka sir hapake. So let's say P1 and color zero pressure 1 and ko makagi sina PA and color zero ka. Adu di yung sida height kesuk difference lay binate ka on a P1 plus rho z h to the higher reg kay the height kesuk difference lay te aduga half rho B1 square is equal to makada di kay no PA katang neba kay no makadi velocity 0 ne wind du kam chain de gyan tai ta de tai ka adu ibitaraga di net force di kay no habita P1 minus PA is equal to half rho V1 square ta so half into rho di kay no rho is so piram ni mo P bra 1.2 and then velocity di kay no 250 no velocity is 40 ni 40 ko adu ergadi 20 into 1.2 ga tar ba udi 2.4 tare ko is it 2.4 at the 20 tare na ko 20 12 into 2 the 24 tare so 24 tare 0 mi awis di yandai ko so this is 24 adu ergadi force ti kaino habda this is the pressure difference neba force ti kaino pressure di force by area ni na ko pressure into area ai tare ko so delta p into area yare ko so delta p di 24 area di kaino area di 250 yantai ko so c ni into toro kai ta gyong so c kamaina c amuka yamna 1 24 into 25 ang tawlem ni ko adona multiply to gunu ko c sir harake munna taw kamain taw ni habda c 24 le ko into ana c 25 into 10 hairoba sigi 25 se nang mathak to 4 am into to makha da 4 am into to shaloba kain 25 into 4 de 100 neba adu si da kai 4 3 or 12 yai ko but 3 the answer yaudra adu de kai kan soire am ka jung soire kai de soino velocity square ne velocity square toram de 40 into 40 see 2 ko so 0.6 yarba 4 4 16 ko 16 zida kedoba 16 is the 0 amatang lowro the 6 amagana toro 0 layer 6 6 36 616 789 so which this is equal to 960 aduna aina cc 960 into 250 lani yareko this has to be 960 into 250 adu ibataragadi kay layer ni have the 960 the 4 na yellow kay tayo 960 layer na ko see the 1000 see amalayer na ko 1000 high roba the 4 na yellow adi kay tarne have the 4284416 0 tarba this is equal to 2.4 into 10 to the power 5 Newton upwards adi kay tare options hai option number A tabre ma'am
Tayo, sir.
taiko so sir gi kho che gyan tabra
Hoy, sir.
sir okay
sir.
sir gi kho che da gyan taw da mi yaubra sai to boss Sunanda Sinthoi adagi Sahila Christina Anjali loinamak kaya to ngambra gyan ta ngambra Lakshmi budi kumakre ka
Tayo.
Sir, ay tat.
tadia
ꯑꯍꯥꯟꯕꯒꯤ ꯂꯧꯔꯛꯄꯁꯦ ꯑꯁꯤ ꯀꯃꯥꯏꯅ ꯇꯧꯗꯦ ꯀꯔꯤꯅꯣ
habdi
ꯑꯗꯨ ꯇꯥꯍꯧ
nate akoina ne kaino tawbudo ngasai Bernoulli's theorem or Bernoulli's principle law matamda kedo we have the p1 plus rho z h1 plus half rho v1 square is equal to p2 plus rho z h2 plus is no yung oriented half rho v2 square na laydana labra laytabra lay ko si sumain laybane ko aduna kaido we have matamda sigi se aina 1 gi sagai sina mathaki sina 1 and low reba ko habdi sarna haning is kaino have the sigi 1 gi kangbu sina mathakta lay sineba mathaki win je aduga sigi kaido ba 2 gi kangbu sina makha da di win ji kem chatteba there is no win yan tabra haidi makha di ka manung ni dana yung gi manung ni dana phalang na loin khajali ni na win gi velocity 0 on sigi tam 0 chakre height ti kaino height ki di kem ta difference laite height laite 0 0 chakre adi p2 khole horoidro p2 du di atmospheric pressure ni haidane moina pa mathak ki du di wind du kana speed chatlam ni na my pressure du kano moram ni khangdre my pressure p1 and option le adi my velocity du di v1 velocity du di my 40 meter per second chatle hamni na half rho v1 square is lower ni si sina mathak ne ba si na 1 si sina 2 yar bujikti
Oh, sir, yari.
मैम लो यार बा no response Yanarbo?
Yes, sir.
There you go. Okay, fine. Now let's move on to the next question. Question number 6. A fluid is in streamline flow across a horizontal pipe of variable area of cross section. For this, which of the following statements is correct? The velocity is maximum at the narrowest part of the pipe and pressure is maximum at the widest part of the pipe. See here no sanam narrowest part of velocity maximum when you have sim chumme, but pressure di kayo ni velocity na maximum or agad pressure sina minimum or tu tra. So first statement is chumbra lanbra. Lale. Very good. Lale. Second is velocity and pressure both are maximum at the narrowest part of the pipe. Si chumbra lale ko. The second is velocity and pressure both are maximum at the widest part. Si lale. These are velocity is minimum. I not sure ba. These kind of velocity is minimum at the narrowest part. Si lale. Narrowest part di kenu velocity maximum mo idune ba. Velocity maximum mo na pressure is minimum mo ba.
So easy to know mal.
Velocity is maximum at the narrowest part and pressure is maximum at the widest part. Natte, pressure is maximum at the widest part. Yes, chumme. Option A is chumme. Aina khali si widest part se uhodreva. And pressure is maximum at the same narrowest part. Ki wena khal reva. Abadi narrowest part velocity is yam yang ni pressure na quite lower ni, but widest part di tappaga pressure do na maximum more ni. So option A is the right answer. 6 option number 8 agada ba. Ma'am gyan tahu bra? No response. Tahu bro?
Tayo, sir.
Tahu
Sir, taho.
Tahu. Okay, fine. Now let's move on to the next question. Rosban, kena tahu bra? Yari ba? Kadi tiang yang changai je. All right, let's move on. Rosban ji. Rosban adum kena tahu draga di kian tadi dum tadi hero nang kadi tiang yang chang pa. Now, matang da ji ko into this viscosity and surface tension. Viscosity question yang mahante. So let's discuss viscosity. Now, viscosity is viscosity is it's liquid layers in marakta relative motion opposed to bagi force the force which opposes the relative motion between the liquid layers or fluid layers the force which opposes relative motion between layers of fluid liquid or gas. That's known as viscosity or viscous force. Now, viscosity or viscous force viscous force or viscosity, it's the same thing. Sisiga friction ga viscosity ga friction ga khar khenai ba. Now, sir, nanui the friction already ta krenui class yahoguna yahore recorded session yeng wana yeng natra hana de masai khangjar kuna khangjar re friction ji kaini haigi sir na. Yes.
Relative motion do opposed over total force
between solid surfaces between the solid surfaces in contact haigedra. With the friction is kind of the force which opposes relative motion between solid surfaces in contact. Again, friction is kind of way in the mazi canonico electromagnetic force when takhaina matamda energy do na maram orga electrons we have the electron transfer tong nei bu aduna haziki surface ani du gi marakta opposite charge si thole ba hadi kedo static whatever static friction or kinetic friction whatever aduna maram oiraga electromagnetic damping gaina haibisu yai kaino di opposite charges si moiji attract tawna banina moini opposite adugi force of attraction duna taptha laine ko that's kedo that's friction yare ko and friction is but again sarna yam ka hena noida yam haijen grade yam luna na khalamani kaimnate friction is solid surfaces ani di marakta relative motion da adu opposite force do friction ko weba ko and viscosity or viscous force haragana ke dawa liquid layers singje moi singji marakta leiba ke dawa force of ke dawa relative motion opposed to force do viscosity ko weba ayuna moigi haurak famje friction gi haurak fam ga viscosity or viscous force ki haurak fam ga mana deba amaduna electromagnetic damping hai electron transfer dai to buneba viscosity di electron transfer dai na teba liquid noi khangam ni ko noi na again noi hoi sir na budi Part-3 noi da ko ke do we kinetic theory of gas kaina ko na lakani ke do we have matam the gas to the molecules sing si moi gi marakta force of attraction lei tien hai ko liquid to the lei solid to su lei kanadan quite den strong way solid to quite den strong way liquid to su dum lei di lei auna ke do ni matam the liquid sing ja liquid ki molecule amana magi akoi bida leiba in all possible direction the leiba liquid khuding makse mana attract taweba yam kanna budi attract tawdrogsu attract tawdi taweba tawbuni na kaidong ya matamda liquid amna flow torpa matamda layer the flow tawena kuini low weba ko adu kaidowai low in have sir hierarchy ba ko but haziki na di low weba layer da adu di kaidong ni sigi layer siga si layer siga sumai leibinarame sida leiba molecule sing siga sida leiba molecule sing je moji sing janaram niba asumai chakki matamda kaidong ya matamda ngasagi force of attraction duna intermolecular forces of attraction duna taptha lakani ba ko aduna sigi aduna adugi potu sarna budhe jik dikito intermolecular forces of attraction between the liquid particles in the taptha lakadine aduni ba viscous force haise but maji kuina kedo we have the maji kuina anko hotpe yana ba ko mathematically describe tora ge ko viscous force haise kaino or viscosity ji kaino na ko let's say pipe lere or whatever turinam lere na haje ko let's say this is the river bed and water ji adum ke doba water ji flow tore si de ko de flow tore am flow tore no flow to matam ji ne mathak ki ji ta sing mathak ki ji dum hai ya holler ge ko mathak ki ji yaw drain low ro adu erge di velocity sa gradient velocity gradient am thola kane bu ko adu kai no ying se bu ko sida di velocity 0 ne ba matang velocity ji kitang yaurakani matang na kitang hena yaurakani matang na kitang hena yaurani kitang hena yaurani kitang hena yaurani kitang hena yaurani ko si velocity gi magnitude ni ko si kano sir blue du dagi hena hendokren khalagasu kem kai de this is the magnitude of velocity do auna ke doni ha matam da all these are velocities and velocity si ke do wa si gi mathak ki sina khwai de hena yang ni and then CD CD velocity 0 ne have the river bed to or makha the quite bottom layer do now CC makha na high one in a cross section low matam the ko makha katang na teba pipe amada ising ji pick ton of flow to matam da any direction they nang cross section low matam da CC na mayai ne ba sina mayai ne ba ko mayai is the we have the magi water do no flow to the pipe to the quite lap jaga ji mayai do hoidena ko the maya have the kind of cylinder hierarchy ke doba axis of the cylinder haitare exist to na quite lape magi manungi wall do dagi ko my pipe to manungi wall do they ko inner lining of the or ke doba inner surface haitare ko inner surface or inner lining of the wall of the pipe haigera inner lining of the pipe they quite lape maya je sidana quite in a young neighbor ke doba fluid ki speed se and then nasagi manungi ke doba lining hai tare ko inner lining da thangnariba fluid sing do moi di rest leba kai no ai matam da surface to moi ge ke doba moi nap nai ba ko adu gi nap na force na kai koi adu again there are two types of force ko hypertrophy palam ge ko sir sida ko adhesive force and cohesive force na ko cohesive force and labor. So water gidi we have the adhesive force ka cohesive force ka with respect to plastic pipe gumba yang no the adhesive force nen chawe ba ko auna sida leiba water droplets sa si move sung to roi ba kai no adhesive force strong adhesive force amna ji pipe to nappa lei ne ba then si sina rest lei re si velocity khayawani sumai toraga mayai na tra na khwai mathak tu da na khwai de velocity ji yang ne ba khwai mathak hai jo wani kai yum si pipe or magadi mathak tu jong rest lei dini ko pipe na ta bi da hang do ga di open or ga di habdi magi nga sai ke do ba di sir na hani bi idea se di kai no ultimately kai no have the inner lining of the okay the pipe haigadra or whatever ko inner lining haigadra inner surface haigadra adudagi khwaidai thapa jaga da adudana velocity si khwaidai yang ne ba si yaningbra sidana race lai duni sidana khwaidai yang duni yaningdabra sarna aija
yaningi sir
sigi makhada dine yam kana yang oi mathakta di freely flow torkani kai gino di my wall da yam lap thuramnina wall ziga nakna rige wall ga da ek thang tainer ga leiba liquid molecules sing the particles sing the race lai ne ba kai no wall di move to the yaw de ba adu moidi nap naraga adum race lai nap na du na kanana no have da adhesive force na moiji phazal la tham ne race da audai kedo mag ek thang na du khara tapkani audai sum this is the Yankalani Yankan Shine to Quamatak Yang ko. Aduna. Anyway, now we have the Haziki viscous force. Let me just explain like this. Munnatauko, it's very important. Viscous force FV. It is directly proportional to it is directly proportional to velocity gradient and the area of cross section the inversely proportional so viscous force 1 second area of cross section viscous force I'll kay hana sinazika with the A dv by dt 1 second ka machine sige hamta dv by dt and seasoner ke ka dv by dz haisira yes dv by dz and harge dz is height this is kind z se height ne khalage ba ka aduna kaidoni ha matam da sida haining is kind have the dz harge di yamna pick pa kind ina mutat pa yawgra ba okay dz say c z axis ne ina dz harge di yamna picture big pa height am low dine ba yam tin big pa dz ra di sidai si po dz oi dine ba ka aduna in low is in gyan bu ta ga dras ta roitra 1 second sidai si di ka dz ina dz id ka ina have da sidai na si po si yam big pa dz am low re ba now dz chi ke dong ni am matam da nak na ri gai ke dong ni pha ba hen ne ba and lapna rigai kedoni phawa handar kani sidi dum icham cham poni sida kem explain to ngai leite ko intermolecular forces of attraction nangna rigai kan gani lapna rigai son gani ji it's again by logic irai lai poni auna kedoni viscous force to these yete inversely proportional hoini ba gyan taita de me no response
Tai sir.
tai ko
Hi, sir.
so aduna ke do si se velocity gradient ko weba this dv by dz sa si terms equina this is known as ke do this dv by dz it is known as velocity gradient now gradient have the kind of the something which varies according to some distance ai tare have sidana ama oramba ngak le mai magnitude ngak le ga nate khara chatlaga my magnitude change to khara chatlaga change to so haidi kedoba magi change kuto si amuna haidi dum hengalagana dum hengakiba handaragana dum handarakpa proportionally oigadam amuk hengat amuk handar to velocity gradient do constant oidrena akoina velocity gradient haina deba or haziki physical quantity dugi gradient haina deba ko haidi karam kanda haini have the adum hengalakpa haidi jaga si sum sidaina si sum chaki matam magi changi sum hengalakpa or sum handarakpa oigadineba gyan daita de taika yabra yai no response Yeah, bro.
sir.
Yeah, iko. Audagi amana we have the sigi aduna we have the viscous force we have it is directly proportional to velocity gradient never. And then C and isu kedoni hamatam the dz kedo sigi velocity gradient C yamna kedoba have the isam samna se sumaina hagisen no ideka area ga velocity ga zai sumaina in har munataw ko it is directly proportional to area. Akuina kedo we have the friction friction the surface area the depend tawgibra solid uneasy solid amaga solid amaga takhaina matamda moini gi marakta leiba frictional force area of the two surface in contact to the depend tawbra tawdabra tawde very good tawde ba ko kaigino have the madi electron ngasai sar na electron transfer na ne ba ko electromagnetic damping makhalam ne friction je but kaiba sigi keno se viscous force madi it has nothing to do with kedoba electron transfer madi kino area liquid layer gi area se chawrige kedoro kani have the more hadi pharak paje molecule hadi sigi layer si le yo molecule me amjina mai mathak ki layer le molecule me mai makha le yo molecule me amji chinga kadoi bai chat khinu na puna le mina jena hadi something like that hadi kedoba intermolecular forces of attraction ja area chawna consider tawrige helakane ba ana kedoni the viscous force area the directly proportional oi audagi friction ji velocity the depend to gibra kinetic friction do kinetic friction the velocity of the two surfaces in contact to the depend to growth of the bro kanam tawde very good tawde ba but sidadi taweba velocity the depend taweba habidi yam kanna chingba habisa yam kanna chingagadi kaidoni have the naknaraga same dz same distance lapnabduda kaido we have the mazi suppose same distance lapnareba si sungchen chendreba phara aroiba kemta yan tai ko ja kaigumba race le di kamai phani si layer ni ja but si layer ni si tapna chatpa kanna chatpa adu kaidoni have the intermolecular forces of attraction ji kaido we have the velocity da depend taweba ko kai phawai chang se helakani ba velocity difference yam lairi gai phawai chang helakani sungcha sungning to phara roi tapna chalagana tapna pharakani something like that aduna adumaina khanba talagana kuina ngasai sir na hagibdo distance to lapi ge distance khenari gai velocity gi chang du kido ba khena ba helakani ba habi dz se sompuro dz ka db ga ji dum haidi directly proportional gi type tani habi the distance between the two layers si hengali gai velocity gap su helakane ba dv do aduga dz si handari gai velocity difference su yam lai roi ko adugi perspective to the yengera natragana kuina velocity gradient oina direct yeng ba have the same dz ta velocity difference yam lai raga di frictional force of the viscous force auni same dz ta same layer ani gi gap to ni ko dz haisa velocity gradient to yam lai ta bata ga di velocity difference yam lai ta bata ga di viscous force yam oi ba ko so C and EZ kuina equation 1 and 2 si hazel laga kaina the 1 and 2 implies that this is it is directly proportional to A dB by dz lani ko so C ki proportionality constant do FB ni ko sa si proportionality constant do kai ko isi se coefficient of viscosity ko ka do ni ba ko so sir ne explain to is in gyan butabra kanam kumak train ta dra malini
Yes, sir.
Aisha.
like so this is known as coefficient of viscosity. Coefficient of viscosity. So main lai ka. So duna viscous force ki formula ji kai no eta A dv by dz. Eta ji kai no eta ji coefficient of viscosity ni ka small n the ka sang sing thab ji ka eta oi din. A ji na kai no area of the liquid layers ni ko liquid layer gi area du ni and dv by dz in a velocity gradient ko ka and see the area is in okay no is in okay no area of the fluid layers ka so my layer yare ka so that's viscous force now makata ka makada kai do zike have this let's do Stokes law. One second. Now Stokes law di khangbra. Stokes law di ne let's say tarak por jai natraga na any kino to jai ka oina tara alazira natraga oina sat halazira. It's a solid amne ka. Mazi velocity v the move to neva. It is moving with velocity v. Kai the move to iba liquid amai manungda. Liquid amalay ko nang si liquid manungda si balls nang lang or push to whatever balls you can move to ka aduda magi kaido we mana sigi solid china fangada viscous force to do kai wini ka. Now Fv is equal to 6 pi eta r v have ka. So you have to know this kind of sisi makhangzalo sisi queen sir ko sisi directly to roige no ko important oide ado 6 pi is just constant ni. Now sidalai ba viscous force si sigi solid sina face to gudri ba viscous force ni ko mangonda ke doni abda opposite oiba force ama mangonda lakane ba chat kinune na that is fb eta fbc asom side ne zakadu is ko fbc mangonda farak pagi force ni ko now mangonda farak pagi force se fb se kamain to we have the yeng se ba ko kaido we si line no magi ke do ba quite first the coefficient of viscosity that depend to ni ba ko ita is the liquid or fluid to gi khatang lai duni ko solid ki di ita laite coefficient of viscosity is only for the fluid aduna coefficient of viscosity wangi gai haziki fluid to gi relative opposition have the opposition to the relative motion between layers wang khala kaduni ba awna for example noina we have the fluids again nungsit ta noina chen baga water gi manung da ising manung da chen baga yamna nang ba liquid let's say glycerin manung da chele kai khala jeba adi viscosity quite wang ba glycerin no quite a viscous drag hen ni ba so this is viscous drag neba fv viscous force adum harsia or viscous drag harsia ke na solid amna flow to with the opposite to viscous force am lak maina ko and then mazi ngasai gi solid to gi dimension do my r do my radius agira my even diameter harsia kem kai de ko adu my constant ka change lani so then magi radius arrow radius to the directly proportional wini my magi my mamai ju chawrige ke do rakani have the viscous drag helakani ba and then mathang da kaino my velocity is directly proportional when you become my velocity to yang ige ke do ba phabe helakani kai di mana liquid layer do puna ba hona do ni da chinga ga di magi surface liquid layer amana mangon da ke do rakani napakani ba envelope to rakani ma je adugi liquid layer do di maga chamana yang na sami da do ne ba but haziki fluid to the restalizer am fluid ne ba auna mangon da envelope to liquid layer do na chain matam da mana chali velocity chatpa matam da haziki mangon da envelope to liquid layer sing duna moiga thangnari liquid layer sing chinga ga kedoba relative motion ama create to rakaduni ba layer liquid layer am ge marakta adugi relative motion du oppose to rakane ba kanana viscous force na kai the viscous force idi kai no opposition which idike opposition to relative motion between layers of liquid hibernate between layers of fluid hierarchy or liquid hierarchy ma'am sisi gyan taita de gyan ta dabra no response
Yes.
Sir,
hello
Ta-
yes kaino
tayo, sir.
oh okay aidi kaino tropod sir na koropod da no gyan ta di na have malure ka anyway where were we 1 second ka duga kai topic sir na ka explain to ba Poiseuille's equation ka duduma towards ka Poiseuille's equation to na fabra ayuda yes Poiseuille's equation ka let's do Poiseuille's equation so sida dum toksalajira sigi page sida ka dum toksalaji ka Poiseulles la ai ka ogre Poiseuille spelling de ka si chumre ngo lala di haro Poiseuille's equation sisina kedoni ha matam da ka. Let's say I'm sorry. Sigi sidane liquid am flow tore. Whatever fluid or jaiko, nungsit or jaiko, whatever flow tore. Now, sidale pressure in a let's say P1 never. Sidale pressure in a P2 never. Obviously P1 ga P2 ga kanan charam ne. P1 am charam ni ka. Charam withdraw. No response. Kaino kanam to respond to oktijibo. Ta bro.
Bye, sir.
Kanam respond to okti. Kaka respond to wrong ne. dB by dt harge ka. Rate of flow have never. So volume by time har. So no see v is velocity ni khalla di to a. This is volume ni ko v is. It is equal to kai again. No constant pi by 8 way bra. Aduga kai da wa. Atai di kai no area of cross section chawrige yang be helani. Ade ita da aduga L da aduga amana pressure difference way bra. P1 minus P2 har si are ba. Aduna R to the power 4 aduga kai da wa P1 minus P2 to delta P har ge ka. Dum delta P dum har ge, where delta P is equal to P1 minus P2 and R is the radius. Adagi A is in a A ga R ga punna di yamina yaroi. Kaina area of cross section ga R ga di punna di yamina yaroi ka. Aduna di akhoi gi si somewhere kaidano ma A si yauroi da bane ma si gi si da ka. Aina A si yausali si A ga R ga si yamina yade ba ka. Adugi ni. So smile then kitang chingat ke. This is known as Poiseuilli's equation. Now hapetang yam sidaka. I don't have to explain much. Kitang explain to ga yam diam da. All right. So munataro ko Poiseuilli's equation is CC kaino rate of volumetric flow ni ga. This is known as rate of volumetric flow. Volumetric flow either. Have the how much volume is flowing through this pipe per unit time. Yareka. It is again pi by 8 is just as constant, and then R to the power 4. Have the R to the power 4 I can have the radius nika. My radius is kino. Kayuma radius square har the area la anim ko. So area the square the directly proportional way but volumetric flows. Volume chow was dagi amana kaino. The difference in pressure between the two ends. Have the aina cross section sidai below the vida sidai sibo danglor zo from the flow torga the seasona kaidova CG pressures in let's say P1 dash and then let's say P2 dash. How the delta P the see them lower kadini pressure difference the ka the minor lower kadini. Aduna kaino have the pressure difference yam lairi gai magi volume cam flow to have the pressure difference yam lairi gai yam flow to here ni has directly proportional way neba. And then my see the way see kaino this is ita is kaino coefficient of viscosity. Coefficient of viscosity chawrige ke dorokane volume flow to tapak kaneba yam nang liquid orgadi the viscosity am wang liquid orgadi tap kaneba two no flow to roiba auna inversely proportional origin. And then kayumba area of cross section chap manarba everything chap manar but length am sangagadi and length to tien baga length teladi ke don't have the volume amount flow to pokini per unit time da length to sangagadi adugi length to cover toraga lanthok na hona bada kaidoni am matam yam changni have the magi volumetric flow the rate of volumetric flow do adudi tapthara kaneba gyan taita de
Taisha.
Amtanga.
amtanga is karamba part na
Viscosity charge.
Viscosity is coefficient of viscosity the coefficient of viscosity chawrige solid se nang sorry fluid se nang ba na khalas yu have the moigi marakta leiba intermolecular forces of attraction je chaw du ne ba coefficient of viscosity chaw ba is auna obviously yam flow to ba yara roidana have the viscosity chaw ba is viscous force chaw du ne ba ꯑꯗꯨꯅ ꯌꯥꯝ ꯐ꯭ꯂꯣ ꯇꯧꯕ ꯌꯥꯔꯣꯏꯅ ꯑꯗꯨꯅ ꯃꯥꯒꯤ ꯚꯣꯜꯌꯨꯝ ꯃꯌꯥꯝ ꯍꯥꯏꯗꯤ ꯐ꯭ꯂꯣ ꯇꯧꯊꯣꯛꯄꯒꯤ ꯚꯣꯜꯌꯨꯝꯗꯣ ꯑꯣꯕꯤꯌꯁꯂꯤ ꯍꯟꯊꯔꯛꯑꯣꯏꯗ꯭ꯔꯣ ꯚꯤꯁꯀꯣꯁꯤꯇꯤꯒ ꯍꯥꯏꯗꯤ ꯏꯟቨꯔꯁꯂꯤ ꯄ꯭ꯔꯣꯄꯣꯔꯁꯅꯦꯜ ꯑꯣꯏꯅꯔꯣꯏꯗ꯭ꯔꯕ ꯚꯤꯁꯀꯣꯁꯤꯇꯤ ꯆꯥꯎꯔꯛꯑꯗꯤ ꯚꯣꯜꯌꯨꯝ ꯔꯦꯠ ꯑꯣꯐ ꯚꯣꯜꯌꯨꯃꯦꯇ꯭रिक ꯐ꯭ꯂꯣꯗꯣ ꯍꯟꯊꯔꯛꯀꯅꯤꯕ ꯒ꯭ꯌꯥꯟ ꯇꯥꯗꯦ
ꯇꯥꯏ ꯁꯥꯔ
ꯇꯥꯏꯀꯣ ꯍꯧꯖꯤꯛ ꯑꯗꯨꯗꯒꯤ ꯑꯇꯩꯗꯤ ꯌꯥꯔꯕ ꯂꯣꯏꯅꯃꯛ r ꯗꯦꯜꯇꯥ p ꯏꯇꯥ l r ꯁꯤ r ꯁ꯭ꯀ꯭ꯋꯦꯔ ꯑꯣꯏꯗꯦꯀꯣ r to the power 4 ꯑꯣꯏꯒꯅꯤ ꯁꯤꯁꯤ ꯗꯤराꯏꯚ ꯇꯧꯔꯀꯥꯟꯗ ꯂꯥꯛꯀꯅꯤ but again this derivation is beyond your scope ꯀꯩꯒꯤꯅꯣꯗꯤ ꯁꯤꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯈꯤꯇꯪ ꯀꯩꯗꯧꯕ ꯑꯦꯗꯚꯥꯟꯁ ꯑꯣꯏꯕ mathematical physics ꯀꯤ tools ꯈꯔ ꯁꯤꯖꯤꯟꯅꯒꯅꯤ ꯀꯣ Laplace equation ꯀꯩꯀꯥ ꯅꯣꯏ ꯇꯥꯔꯝꯒꯤꯔꯣꯏ so again that is beyond the scope even JE ꯒꯤ ꯑꯣꯏꯔꯒꯁꯨ ꯑꯩꯈꯣꯏ derive ꯇꯧꯗꯦ ꯀꯩꯒꯤꯅꯣꯗꯤ ꯅꯣꯏꯒꯤ scope ꯇꯩ ꯈꯤꯇꯪ ꯀꯩꯅꯣ ꯑꯣꯏꯅ ꯆꯠꯂꯦꯕꯀꯣ ꯑꯗꯨꯅ just remember this formula it's a very simple formula ꯅꯣꯏ dimension ꯅꯨꯡ ꯈꯔ ꯈꯪꯖꯜꯂꯣ ꯑꯗꯨꯒ ꯌꯥꯔꯦ ꯀꯩꯁꯨ ꯌꯥꯝ ꯀꯩꯅꯣ ꯇꯧꯕ ꯁꯤꯗ ꯌꯥꯝꯅ ꯀꯣꯛ ꯀꯟꯅ ꯊꯥꯗꯒꯗꯕ ꯅꯠꯇꯦ but ꯅꯣꯏꯅ ꯒ꯭ꯌꯥꯟꯗꯤ ꯇꯥꯒꯗꯕꯅꯤꯀꯣ ꯍꯥꯏꯗꯤ ꯀꯃꯥꯏꯅ ꯇꯧꯔꯒ ꯀꯩꯗꯧꯕꯒꯤ inversely proportional ꯑꯣꯏꯅꯣ ꯀꯩꯗꯧꯕꯒꯤ directly proportional ꯑꯣꯏꯅꯣ ꯍꯥꯏꯕꯗꯣ ꯃꯌꯥꯝ ꯂꯣꯏꯅꯃꯛ ꯌꯥꯔꯕ ꯁꯤꯒꯤꯁꯦ
ꯌꯥꯔꯦ ꯁꯥꯔ
ꯌꯥꯔꯦ ꯁꯥꯔ
ꯌꯥꯔꯦ ꯁꯥꯔ
ꯌꯥꯔꯦꯀꯣ ꯔꯣꯁꯕꯟ ꯇꯥꯕ꯭ꯔꯥ ꯔꯣꯁꯕꯟꯒꯤꯁꯦ ꯋꯥꯗꯤ ꯉꯥꯡꯄ ꯃꯥꯜꯂꯦ ꯑꯗꯣ ꯃꯈꯣꯟꯗꯤ ꯑꯝꯇ ꯇꯥꯗ꯭ꯔꯦ ꯃ꯭ꯌꯨꯠꯇ ꯂꯩꯕ꯭ꯔꯥ ꯅꯪꯒꯤꯁꯦ ꯅꯠꯇ꯭ꯔ ꯅꯪꯒꯤ ꯃꯥꯏꯀ꯭ꯔꯣꯐꯣꯟ ꯌꯥꯗ꯭ꯔꯕ ꯔꯣꯁꯕꯟ ꯇꯥꯕ꯭ꯔꯥ ꯇꯥꯗꯦꯕꯨ ꯅꯪ ꯋꯥꯗꯤ ꯉꯥꯡꯉꯦ ꯍꯥꯏꯕꯗꯤ ꯈꯪꯉꯦ ꯕꯠ ꯇꯥꯗꯦ okay ꯆꯦꯠꯇ ꯀꯨꯝꯃꯣꯀꯣ anyway so that's Poiseuille's equation ataydi kai leiri noida kaino tawgadaba haibada I don't think viscosity gi oinadi sigisina loiraba natragana noida kaino hajiki siga chanabada topa kai takpa yai haibadu ma yengsi ko atopa noida kai takpa yai habada aina sarna noida terminal velocity to takthorage ko si matang hida chanare ꯄꯨꯡꯗꯤ ꯀꯌꯥ ꯇꯥꯔꯦ ꯌꯥꯅꯤꯗ ꯑꯩꯈꯣꯏ ꯈꯤꯇꯪ ꯊꯦꯡꯅ ꯍꯧꯏꯗꯨꯕꯀꯣ terminal velocity now terminal velocity kaise yam nungai concept nebako noi si khangba kan noi harau neba aina ngai si khangamdre ne terminal velocity je noina khanjan da pot ama sarna hairakani ba terminal velocity gi matang da ko let's say there's a fluid ama layebako let's say kamai hajige container am layebako container ji da fluid yawa yareko now see the solid ama tareba solid ama kedoba makada tareba tarakpu matam ni maji constant velocity tarakadra maji sum yankalakadra haibdi wane ko adu do koi khanajeba yan dai gaja now kedongni hai matam da thanks stop toge ko tar podamaji mathaktagi tarakpu matam da acceleration due to gravity z da kedorkani potse accelerate orkani ko ai si free fall ni ko se free fall neba cc aina thadokpu matam velocity 0 ne u is equal to 0 but sum yankalakani sum yankalakani sum yankalakani amaji gyan tai ta de tai ko
tai sir
now
Yes,
pot
sir.
ama thada matam da sum yankalai dana adu kai do ya matam da ngasai gi kuina Stoke's law do akuina ngasai gi ko ngasai Stoke's law da kai do gi yang ga di viscous force to kai do re Stoke's law da solid amana ne chatpai magi velocity ji yang e kai do rakane my viscous force heleba gyan daita de phabai chang ji heleba di velocity da directly proportional oeba aduna di kai do wi have matam da pot amaji thadarakpa matam da ne my velocity sum yankalakani na velocity sum yankalakpa taragadi again sir noi da haigada babu air je fluid amaneba air gi wanate noina water gi manung da or anything any liquid amai mang thadaragazu viscous force engalakani air or any liquid any object amanang na thadaba matam da ne my velocity is acceleration due to gravity na maram jar engalakani yankalakani but yankala imatic viscous force phabai changju engalakani ba gyan tai ta de tai ko aduna at kedoba abdi mai yankalakpagi chang ama yorakpa matam da ne mai viscous force to adugi matik chawrakpana maram oiraga magi weight adi magi acceleration due to gravity adi maji man taraiji kaino man taraiji mai weight na taraine weight aji kaino weight ki kedoba kuina weight ki for weight की formula जी कहीं mass into acceleration है भाई weight as force नहीं देना है weight की formula जी कहीं small m into z होता ना है mass into z होता ना को mg होएगा so मागी weight to ga viscous force to ga ani equal and opposite or kan de ke dor net force is 0 or ne ba haji ki body na fangi ba net force is 0 or ni na pochi ke dor ne further ma ji yang khala roi ba tarak ba accelerate to roi ma constant velocity tarak ne ba gyan tai ta de ta da bra
Tai sir.
tai ko aduna kai dong ni ha matam da akoina for example let's say sigi constant velocity da tarak ba ji ne ba ko noi de kamai na hai ji ga matam da let's say akoina ne noina sum noina kai gumba plane gumba dagi ko helicopter dai na tragana aeroplane gumba dai mi chongthara ga moi different formation ga cm dana ko tana makut ka paina dana udagi kai soina kai ne whatever spin ga tawdana ko tana myam tawri do adu akoina kai khalle ha moi di weightlessness feel tawda jala moi di hainadaba phawda jala akoi di gari tongba matam da angambi ama pat thawgalura bang long thawda matam da khangtaw thawda da mi hunji pai thoke ga tawidana and then merry-go-round gumbagi tongba natragana bungee jump oigera ko adain to matam na mi hunji ngatang haidi weightlessness feel tawuji isade am nungai tabane yam hainadam neba aduaina ma feel taweba adudi moi di am tina daring oibagi haidi moi plane apaiba plane dega chongthrai dana ko hoi chongthabai ji pura makha da direct yodong nate parachute open to rakadoi ngak le kanda ko habiti ground yodringai ta but that's another story sarna haining isina moi di pakhattaba jala ba moi di mihun ji paithokta jala ba akoi di mihun paithoktra so moi di odai chongthra ko paithokta jala haragadi noi ju akoi ju ne odai chongthaba da ne mihun pai di paithokani but kit ngatang khak ne ba paithokadoi ji gyan da rai ji isa de mihun paithok pai di khangi ko nungai tabado lift gumbor ju khangta ta gi matam no wang long isa da kainom phawdo adugi kainom ma phawri do weightlessness ko weba gyan tai ta de tai ko
Tai.
aduna nang na kai gumba plane amadagi natragana awangba jaga amne nang chongtharakpada nang ji weightlessness phawni ba acceleration due to gravity ja long tak matam nang weight to mangi be tap ta nang weight cha nang physical force nang id tara amni na ko mg da tara nang id weightlessness phawni ba but kaido we ha matam da ngasai gi nang sum yankhala imatik viscous force is sum yankhala kane ba ko aduga last da kaido ne ani je balance or kanda kaido kani nang ji yankhala roi further sum yankhalani viscous force sum chakhalani at a particular point nang ji further yankhala roi kai ginodi nang yankhatna bohonal si som the opposed to viscous force to chap manaraga force ani ji equal and opposite oina ramnina same object nangonda ne act to force ani ji na amana chingtha doiba amana pha doiba equal and opposite orni ko si yankhalak tamina viscous force chakhala roi ba auna constant velocity tarane ba adugi constant velocity do yamna few seconds yoweba ek chongthabaga yandabra aduna second kharai manung nang ji nang weight myam paithoki myam dong lo yawra ne ba hoi noina awang bude yeng thabde ki bana amani ko mihun paithok du paithoroi ba mihun do loi changa ne ba sarnai ning ji gyan tabra tade
Tai sir.
tai ko ni man khatang khumai ji kai anjali man thang khumai ji kai christina tadabra lakshmi
Tai sir.
rosban tabra udagi setabo sintoi
Tai sir.
dum sir
Tai sir.
equilibrium da leiradi adum lepaga leiroi draw equilibrium da leiragadi lepa leiroi equilibrium da leiragadi adugi moment da leiba velocity to the move to the neba uniform velocity habdi na haji force and easy cancel to we haine ba equilibrium da yes a kind of equilibrium neba habdi kaino habda force and easy balance out or cancel out to greba but cancel out to wagi moment to the mazi uniform motion da chatpani na adugi uniform motion to the adum chatkaneba gyan taita de rosban yarba nang na ngai question dem phajai ba ko equilibrium again equilibrium haibudi yabra have the yes force and you cancel out tore net force later but adu moment to the mazi rest later magi adu the velocity do adu dum ta ne ba dum yang dum paitharakane but my immune du pai thoroi kai you know have the mazi further accelerate to dreba mg de edi my z de accelerate to dreba akoina immune pai to z de accelerate to kan ne ba yan dai ko weightlessness power do power roiba weight myam do changa ne ba kai you know di ai kai do we have the makada for chingda haidi soina kai do ai weight to mg do adu soina tarak pu decision na treba ko ai constant velocity da taramni na ai weight do changa ne aduna akoina ngatang khak hek chongthabaga plane dagi or helicopter dagi parachute pudi nanganda haptoini ko aduga hek chongthabaga mi hunje paithokrani ba weightlessness power ne ba but within a few seconds I weight me the low in amount changa ne ba kai gino I'll be falling at terminal velocity constant velocity tarakane gyan taita de tabro me amne ma
Hi, sir.
Hi,
Bye,
sir.
sir.
adudi aina ziksi sabudi noida can we explain tawre but equation oina hotozi ka equation oina equation oina hotpa matam dadi kuina ke doni have the my weight to w do kai ga manani have the viscous force ka buoyant force kai you know have the every fluid has some buoyant force magi body do na fluid khara di mana displaced or me adu displaced or fluid to weight to upward force of buoyancy oina phangani na adu du mana bam thoe ba ko aduna di yeng asi ziki body ziki magi density zi sigma nen lower ge aduga kainogi fluid ki density jina rho nen lower ge ko sometimes rho ga sigma ga change tona ba yaw bani solid kina rho lower ga liquid kina sigma lo ji yaw bani ko no ya pam bani sir na si lo ji ya mun ne yeng ko si matung in ne san tor ka de so weight have di kaino w is weight di kaino mz but what is m di kaino density into volume di kaino 4 by 3 pi r cube natra so now I'll just use sigma natra sigma z okay karamba lo zige sigma lo tam ni si gi oina de ni si sigma lo ni ko now sigma ga ro ga ji noi ngau na ni ko like tana atopo oram ba ji ya have the ro ji na si oram ja ko ai ne khan ma si da ro oi ma adum noi gi like dum follow tors yeum ko class lo idare this is rho this is sigma adu irgadi kaino have the m gi muta rho harga 4 by 3 pi r cube z m ni ko this is m and this is z m digan density into volume now magi viscous force di kaino viscous force is 6 pi eta rv plus kaino magi kari magi buoyant force di kaino sigma 4 by 3 pi r cube into z can daita de taiko sisina liquid to gi mana displaced or liquid to volume do my volume do chamana ni na into z on upward force never so c is the other regadi my is the labor v do putho have ni so it's very simple v do putho z v z kai tani ong sida 4 by 3 pi r cube c common low raw 4 by 3 pi r cube c common low raw adu z is common low raw adu di kaino have the rho minus sigma leni divided by 6 pi eta and r leni adu regadi kaino have the 4 by 6 3 kana 18 so adu di 2 by 9 leni pi cancel sakre r square leni then z leni kon then rho minus sigma leni divided by harga kaidoba this coefficient of viscosity ka silane gyan taita desi gize tabra ma'am taubra
Taoism.
tawiga so this is the formula for terminal velocity now terminal hai se kai gina the final velocity ne si velocity is the here ne yang kaloroi ba si poto gyan taita de tariba pot sa si velocity he ne yang kaloroi ba rosbana is kai no adum taraga di sir ma mg na chawi haiba oiloi drop balance to we haiba do kamaina ta haibi sir okay adum tara ido mg na chawi haiba na teba rosban adum tara ize mg na chawi hargadi mazi adum yang khalakadabane ba acceleration due to gravity na mazi every second kudingi after every second magi velocity zi 10 adum hengalakadamne or 9.8 adum hengalakadamne ba but mazi constant velocity to the tarai do na takpadi mazi kedoba accelerator of treva have the force of gravity to lay treva mona di lay neva but viscous force to na opposed to orga pha greva have the ani do equal and opposite oi greva but equal and opposite oirakpa moment to the co at that particular kedoba instant magi velocity am di lay ma race lay teva adu velocity to the adum chatkane mas gyan ta da rosban okay fine yare ko sing ko no yum ka adu mayam kenu to bra loin ma gyan ta ra si gi Tadabra hairo gyan tadadi adum seng adum hayo ko gyan tadadi tade adum hayo. Yarbo no response. Yarbo ma'am.
Yarani.
Yani ko pung ji kya ta hai pung 9:50 bu ta le me ko. So this is the formula for terminal velocity. Now question na mani ying sira viscosity ga. Question kya bu yam je question yam din tu question amani hum ko tang ne taw tho ji je question yam man te ko phalang taw tho si ko question yam kuin chang we je noi wa bu di war mani khang but hayeng je surface tension ta ga capillary rise ka ta ga hayeng adum lo shil lage fluid se ko hang chi test lai dan noi ga so fluid se question chaw chapter na te ko and yam live chapter singi manung da amani fluids hai chapter ji mani two small spherical metal balls having equal masses are made from materials of densities blah blah have radii of this and this respectively. They are made to fall vertically in a viscous medium whose coefficient of viscosity equals this and whose density is this. The ratio of the terminal velocities would be. So it's a very simple question. I'm live question. Anyway, V1 is equal to hazikito kay tagi matagta 2 makada 9 ita r square legidra r square kay nagda rho minus sigma ra rho minus sigma kay legi z or see the z lebra. Okay, am I right? 2r square z rho minus sigma. Yes, 9 eta 2r square z rho. Okay, fine. Si leba ba si terminal velocity ni hai v1 by v2 hai matam da ko ita di kakthak karani ko aduga 2 le ni ko r square is having two small having equal masses are made from materials of densities rho 1 and rho 2. Okay. Rho 1 is equal to 8 times of rho 2. Yam phazai. The same mass in a mass by volume 4 by 3 pi r cube is equal to 8 times m1 m1 to m2 someone same mass but my volume is the kind of 4 by 3 pi see r1 cube nika see in r2 cube never 4 by 3 pi ka kre 4 by 3 pi ka kre m ga ka kre do the kind of matam da r2 cube is equal to 8 times of r1 cube which is equal to 2 r1 whole cube. It implies r2 is equal to 2 times of r1 for j. Aduragadi kaino have the mathaki sida aina r1 square layer ni ko then 90 is going to krani yare ko the mathang the case as density is kaino made to whose density is 0.1 times of sigma 2 have a rho 2 have a okay fine so c is in a rho layer minus 0.1 times of rho rho 2 haita rho 2 okay fine 0.1 times of rho 2 haita okay all right so aham bagisina rho okay rho ka rho z e I have to write here first one all right so so antamazi z suka krani ko even ke do ba 2 suka krani even a sigi 2 suka krani hata kem kana de ko ade mathang is na kaina abda r2 square gi moto 4 times of r1 square lani aduga magi solid city kaino habda magi solid city 8 times of rho 2 neva 8 times of rho 2 neva minus arga fluid city 0.1 times of rho 2 dum oidine ba ko kaino mi chang pa ya da ba yar ba so accept it already but still can to je ko anyway sumai lai juni ko kaino chatise sisi oh sorry sisi kitang mathakta chingat ke ka what now sigi kaino se sigi rho 1 se c rho 1 ne ko sengbudi kaino di ahamba solid ne rho 1 gi motaina 8 times of rho 2 na highway ya ko sise is it yes this is 8 times of rho 2 and sisi na rho 2 dang haigada in 8 times of rho 2 is sorry rho 2 dang haigada mayam sir na haisi gyan tai ta de sa sam tai na ro gyan tabra no response gyan ta dro bono I will see 1 by 4 r1 square ka kreko 8 minus 0.1 dikina 7.9 la 7.9 plus 0.1 8 ta ni ka adu 1 minus 0.1 dikina 0.9 la yes kaino this is the hapsala dite so 1 ta ni ka okay fine so C I get somewhat like this so oh the 79 by 36 tabra yung ma'am yengom ta tabra kanam respond to Anjali Christina Lakshmi
Tayo sir.
Taylor Rosban Saitobos Sintoy 79 by 36 tabra yung answer tay ko
Hoy sir.
so sir no whole is gyan tabra yung sir no whole is answer ta bata da arrive ni sir no whole is gyan tabra yung me no ina sir no whole is ne ba keno to goda gyan ta ga da ta draga di kai de gyan ta de haro kanam kuma train to is
Nani sir IQ hindi.
yani ba sir na sida jida keno pige ba Noi ngor ga row 1 have a set 8 times of row 2 ne ba and row duga kai row 2 di yare they adum row 2 dum nei jare na ko duga sigma zina kai no have the 0.1 times of row 2 ne ba ko aduna everything in terms of row 2 dai na eb1 ne ba ko that's it atai 9 ita z don cancel sakran 2 2 loin ma cancel sakran ni da yan dai ko ade amna kai no have the r2z 2 times of r1 ne ba sisi maga sizinai ba ne ko atai di sinadre yare ko yaine lorgan
Yeah, sir.
okay anui what's one ko just a few more seconds tare sik question ge ani dang ni ne question ahum bu su baining ore question ani dang ni as se loire se question ani dang ni ko so questionless what's one ko questionless ji hayeng di amna line ni ko surface tension ka ji am live topic ni magi pressure difference in a liquid drop liquid bubble ka yam tin live in capillary rise ka dung live leite ko quite a live chapter ni sir na ji to yi yeah so a small sphere of radius r falls from rest in a viscous liquid as a result heat is produced due to viscous force the rate of reduction of heat when the sphere attains its terminal velocity is directly is proportional to very simple my kinetic energy do put one in a tracing we know my terminal velocity formula to energy da 209 eta sida like da r square ka then z okay rho minus sigma something like that ka okay fine heat to energy to kaina kinetic energy hoine ba now kinetic energy to kaina half mv square hoine ba adu di kaina have da that will be directly proportional to r ji dong to r to the power 4 tane option number kaitani option number d tabre yong ma'am amte yong tabro
C tayo sir.
kaita ba
C.
R2 power 5 to size, sir.
r to the power 5 tayo ba okay adu oi bataragadi ko kay yujan yengsi ko half mv square ni na ko mz a small sphere of radius r falls from rest in a viscous liquid as a result heat is produced due to viscous force okay 1 second kai din ko ngai as a result heat is produced due to viscous force the rate of production of heat when the sphere attains its terminal velocity is proportional to okay, fine. So viscous force 6 force work done velocity in kinetic energy and then viscous force is 6 pi eta RV potential energy plus no do the ROI mana terminal velocity attain the my kinetic energy the rate of production of heat when the sphere attains its terminal velocity is proportional to R mass depend the mc liquid mg my is my m have density of the solid C mass by volume m rho into volume and rho volume r cube and velocity square d somewhere sir rate of heat the power netro okay yes rate of heat the rate of production of heat have or do the power ni okay fine yes heat ne khali jao thank you ko ai so enter mit che takan rate of production of heat adu the yes the kai tani yang sika power so this is the energy so rate of production of heat it has to be d by dt is 6 la 60 la oida adu the de by dt ne mo put wise de by dt di the my velocity constant everything constant oh no still kedaba magi kinetic energy constant already okay kinetic energy constant already energy C increase with the torque train of the highway but again with respect to time the mass constant aduna mass 0 z combined torque lakadino have the one so 1 second combine to we have the aduna ina magi terminal velocity delay power g a kind of force into magi terminal velocity na da intoraga energy tarakpa yana di labra habda layeba adumaina khana wana fagadra yengzi so aduna akoina sisi simdi tadre my terminal velocity power name put let's say if I have to find the power d by dt is equal to again p power d force f dot v which is equal to fb the minus vi cos 0 degree d1 this same direction on fb what is f the 6 pi eta rv and then magi velocity is v there okay fine so CDK in time is the v square line v square the r or r the r to the power 5 labor but again c give v r to the power 5 tie has a force viscous force f line f dot v okay so r to the power 6 pi eta r lane and then v is velocity is the smile is years 2 answer budi tare answer 2 2 r square z rho minus sigma divided by 9 eta lane c whole square lane gyan tai ta de sig se tabra kai no di velocity se today on v dot v ne ba v square mc la ne ba how the ultimately some k times of r to the power c r square ga c square 4 c r g the r to the power 5 tabra si se tai ko gyan tai ta de yarbo sig se me
Hi, sir.
yeah, so c is r to the power c square 4 layer and c r is r to the power 5 layer. I do the any side so aduna minus yung question je ko no kitang check law tiktok so have the no first instance mo r to the power 4 je happy ram this podom ne confusion talk to na mai ta kai research so in ta ko no you don't so be a chance so lay ko adu gi kitang sim check law di hana dagi hana thing na aduna ne sir na do every chapter kuding question je so ama ni gumba chahi mai am ni manung da yarok ka ne ba kitang noida okay any soy be ya by chance hai tare ko no haitaba gira have not ba sir soy jam mit thak pani khang de natraga khanda udam ni khang de something like that adui poto le hello ya ga exam nung da no idu ke ba repeatedly no revise to da hanjan hot ka dam ne hanjan hot la kan da di ke dro kan ya tab no ida kira roi ba pot se ka aduna adumai le de ne ba ka so anyway makada queen ke do sige have the surface tension to on surface tension the next class to sigo anyway yare ko do thank you everyone have a good night thank you
sir.
Thank you,
Good night.
Good night, sir.
good night thank you for the class good night